Okay, I was asked to do a superposition video concerning worksheet 13. Basically what we have is a T circuit, 3 resistors, shape of a T, 2 voltage sources. Now the voltage sources are at different frequencies and they have different peak to peaks. One of the frequencies is 100, the other frequency is 350. So want to build and observe the waveform, but then later on you want to analyze it. So I'm going to use those frequencies. I may not use that peak to peak, one's 5, one's 10, but one of my frequencies is 100 hertz and my other frequency is 350 hertz. I've got a spreadsheet open so I can do my calculations. Let's see, V1 is 5 volts peak to peak and this one is 10. My resistors are 5.6, 10, and 15, so we'll just do 5K, 10K, 15 for the purposes of the video. If you're actually doing the if you're actually doing this to turn in, you need to use the values I gave you. Okay, so now we just basically want to build the circuit. So I've got LT Spice open already. So I need 2 voltage sources. V1 and V2. I need a ground. And okay, now I'm adding resistors, 1 in the center, and then the 2 to make the T. Going to connect the dots, draw the wires. And this is pretty straightforward for LT Spice. Very easy, convenient. Okay, now I'm going to set the first voltage waveform, and I'm going to show you transient analysis first, so I have to set it up as a sine wave. When I do superposition, I would set it up and do just AC analysis on them. And when I do superposition, I have to do each power supply separately. So I would take one power supply out and I would put a wire through it, and then I'd analyze based on the other power supply, and I could get readings for all the voltage drops and all the current due to one power supply, and then repeat it by putting that power supply back in and taking out the second one. So I would do analysis that way. So with superposition in 2 different frequencies, you got to do 2 different analyses, one with each voltage source, and that is what you would put in for the 100 hertz readings, the current and the voltages based on the 100 hertz. And when you did the analysis for the 350, you'd get all your currents and your voltages for the 350. So that's how you do superposition. And anytime you have 2 different frequencies, you have to do superposition. And you put your values in, and it'd be pretty straightforward. Okay. Going to go back to the circuit. And what I want to do in the circuit is I want to do transient, and I want to do 3 complete waveforms. So I have to find my highest frequency, and I have to do 1/10 of 1 cycle. That has to be my sampling rate on transient analysis. So I'm going to minimize that, go back to this circuit, and I'm going to go in and set it up for transient, sine wave, my voltage, and I'm using 5 for amplitude. There's my 100 Hz frequency, and I'm going to do a number of cycles of 2, and everything else I can leave 0. And click OK. And then I'm going to set up my resistors, 5K, 15K, and 10K. I'll set up the other voltage source. Got to go to advanced. It's going to be a sine wave again. Different amplitude, this time 10. Different frequency, 350. And if I did 2 cycles at 100, then 350 is 3.5 times is 3.5 times, so I need 7 cycles to get approximately the same time. So I've got that all set up, and now I'm going to go and set up my simulation command, and we're going to do transient. My time to start saving data can be 0. My stop time will be based on my 100 Hz frequency, however many cycles I want, and my maximum time per step is on my highest frequency. It's going to be 1/10 of it. So I'm going to take 350, my highest frequency, I'm going to divide it by 1 into 350. I get that value for time. I'm going to round it to 0.003, and that would be the time for 1 period, and I need 10 samples within that time period, so I'm going to have a sample rate of 0.0003. And that's my sample rate, or my maximum time per step. Okay. Time to start saving data. I don't have any reactive components. I can start it at 0. So here I've got 100 Hertz. Going to do the same thing. 1 divided by 100. And 1 divided by 100 is 0.01. You shouldn't have to do the math. If you do enough of these, you'll get it. And so my stop time will be for 3 cycles. Now I had said only do 2 cycles, and I'm putting in 3 cycles, and you'll see what I'm about to get. My time to start saving data, like I said, can be 0. And my maximum time per step is 0.0003. And click OK. Put my transient in there, and then we can simulate it. Now, the only thing practical to look at is from an oscilloscope standpoint is the top of the 15K resistor, because the other side's grounded. If you build the circuit and you add a ground, you got to be careful with those. So I'm just going to look at it, and what you see is I've got one sine wave riding on top of another sine wave. So I got a 350 riding on top of 100. I went past 21 milliseconds, so I went into a 3rd cycle, but I only told it to do 2 cycles when I set up the waveform. So I'm going to go in and fix that. I'm going to change it. instead of 0.03 I only want 0.02. Okay, now run it and look at my waveform. I got the whole waveform now. 2 cycles of 100 Hertz with a 350 riding on it, and that's what it looks like based on what I set up. And you can see that the two kind of interact. Now if you were to measure the voltage, your meter would report something, and it would be the sum of the two RMS voltages. But this is what the waveform would look like. A lot of times with a meter you're looking at a number, but the number represents a waveform that looks like this, particularly if you have multiple. If you have a signal coming in, say from an antenna, it looks sine waves upon sine waves upon sine waves. Okay, now how do I do superposition? So I'm going to cut out this voltage source and make it one voltage source. It's a sine wave. I'm going to go up and do AC analysis on it. So I'm going to do my AC analysis, and I'm going to do a linear sweep at 1 point, and start frequency, stop frequency is 350 for both. And then I'm going to click OK and put my AC command card there. And transient got the semicolon, so it's not active. The one with the dot is active. And I'm going to run it. As you see, I get 0 because I didn't change my waveform, and it says no AC stimulus found. So anytime you go to AC analysis, you got to go in and change your sine wave. I'm going to click it to none, and I'm just going to go small signal AC analysis. So I'm going to put in 10 volts there, click OK, and it changed it on my schematic. And now if I simulate run it, I get values. With those voltage values and those current values, assuming they're right for what I gave you for the worksheet, you could just then transfer them into the homework. There would be the 350 Hertz values right there. Now I'm going to put that power supply back and do away with that one. And I got to change my AC analysis to the right frequency. You got to make sure you do that part. And then I'm going to get the 100 Hertz. Or that would be the step that I would do. So I'd put in the power supply I deleted, change my analysis to 100 Hertz. I would take out the 350. I would short it out just like I did the 100. And I would do the analysis. And those are the values you need for this part of the worksheet. And you have to use the right circuit above. So that's pretty straightforward, 4 through 9. Then I've got you building a spreadsheet, and pretty common equation. Probably do that on a second video, because that will need a little more explanation, and I don't want these to be too long. But you've got those values for the 100 and the 350, and so we should be pretty set. I'll do this one on the second video. And thank you for watching.